Very good morning to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? How you are doing, everybody? कैसे हो सभी लोग? I hope all of you are doing great. Right. चलिए आज का सेशन हम शुरू करेगा. First of all, you can tell me now here how you have performed your gate. You want to check your gate result. So that is the most accurate gate. The most accurate gate rank predictor which is live. You can check your rank. And here what we need to do here, you can simply copy the response sheet and paste in the rank predictor, an academy rank predictor, and simply you can able to predict your rank. Now we have started the new batches. We have started, you can see now here for 2027 के लिए, and the batch is started from 24th Feb onwards. You can see the top educators team आपको एक साथ मिलेगा. We started the new batches on the networks as well as digital we started. These two are the very basic subjects so that you fellows can able to get the maximum benefit and do attend these sessions to have a great learning experience. And the new batch, this section batch for 2028 के लिए we started. So 24th Feb onwards is running. So here also we have the networks and then digital. And you can see now ESC 2025 ka rankers from an academy team. Look at here. So many rankers are there. An academy starters kit which is available in all the stores. If you want, you can able to get it for just 199 rupees only. And another greatest feature of an academy is an academy AI tool, that is an academy Una. With this, you can able to communicate with the different modes. One is voice mode and the quiz mode and smart summaries. Voice mode, quiz mode and smart summaries. And voice mode. So with this you can speak with and interact with the AI tool. And you can test your quiz. If you ask the prepare a quiz and so topic, and here it is able to create the quiz and smart summaries be. So if you want the summary of the so content, so it will briefly summarize. It will be very much helpful before going to the exam. And the test series which is live, you can access it. And we do offering the two subscription. One is plus subscription, the other one is iconic subscriptions. And plus में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स होगा, evaluator test series and structured courses and PDF, live test, unlimited access. आइकॉनिक में और क्या चीज मिलेगा आपको? यू कैन सी ना पर्सनल कोच मिलेगा, फिजिकल नोट्स मिलेगा, आस्क ए डाउट फीचर and all the features of plus subscription. Right now you can book your mentorship according to time convenience, book a session and slot and connect with your mentor. And these are the 2025 rankers from an academy. Right. 1 minute. right? चलिए, last we have discussed some problems now, and we'll continue the remaining problems. Yes. Yeah, take this problem. In the sequential circuit shown below, if the initial value of the output Q1, Q0 is 0, 0, what are the next four values of Q1, Q0? Initial state. First of all, you can see now this is what type of counter, you tell me now. Asynchronous counter. Asynchronous counter, up or down counter, you tell me. Asynchronous counter, and it is up counter, down counter, you tell me. So first of all, this is what, tell me now, asynchronous counter. Asynchronous counter, and we need to see this thing as up here, down counter, we need to see. Yeah, look at now here. So clock is given Q say, and trigger is positive trigger. So that means what we can say now, Q into plus. So that means which will come it as plus Q will come now. Plus Q का मतलब this is in कौन सा state में है, that is in the सुख में आई. अगर सुख में आए तो सुख के बाद क्या आएगा, दुख आएगा. So that means, so this is a down counter. So that is down counter. Yeah, you tell me now, if it is a down counter, if it is a down counter, now you tell me now here, sequence. So initial state is given as what, tell me now, 0, 0. And इसके बाद what will come here, 1, 1 will come, down, decrease. So here, thereafter 1, 0, thereafter 0, 1, thereafter 0, 0. These are the states will come now, tell me. So कौन सा option you see this thing? Option A. Next, what are the counting states for the counter shown in the figure? Counting states they are asking. See, tell me first of all, what type of counter is it? Synchronous counter. So, synchronous counter के लिए we need to form the tabular form, so we need to form it. Synchronous counter now, so we have to form the tabular form. Let's form a tabular form here in this case for the synchronous counter. Right now you can see now first one here, they given J1. J1 कहाँ से आया, you can see now here, Q2 bar से आया. That is Q2 bar से. K1 is also Q2 bar only now. That is also Q2 bar. Okay, next J2. J2 given as Q1 bar, and then K2 which is given as 1. So we can say output of Q1 plus, and this is Q2 plus. Now fill the tables, tell me now. Yeah, initial values mentioned or not mentioned now here? So initial value not mentioned, we can consider initial values are 0. So initial value both are 0, 0. Tell me what will come here. Q2. So we have what, tell me now, Q2 bar. Q2 bar means what, tell me now? 0. So this is 1 and this is 1. Q1 bar is 1 and 1. 1, 1 toggle. 1, 1 toggle. Next, Q2 bar. So that is what I'll now 0 and this is also 0. Q1 bar. So 0 and this is 1. 0 0 means what tell me now? 0 0 hold state. 0 1 is a reset. Next Q2 bar. This is 1 1. Next Q1 bar. So 0 and this is 1. Tell me now 1 1 is a toggle. 0 1 is a reset. Yeah. So this is the states we are getting now here. So that means we are getting it as a 1 1. Thereafter we are getting it as 1 0. Thereafter we are getting it as 0 0. And again it will come back to initial state only. Yes. So new batch will be run. New batches regularly will start here. Every week we start the new batch. Okay. So even if we join now, you can able to access all the previous classes also. You can able to access it. All the previous classes you can access it. Okay. Next, for each of positive edge triggered JK flip-flop used in the following figure, the propagation delay is delta t. Which of the following waveforms correctly represent the output of Q1? Tell me now here. Each flip-flop will have a delay. How much the delay they given? It is a propagation delay which is given as a delta t. Okay. And thereafter, so what will be the output? First of all, you see this thing here. This flip-flop will have a delay of delta t. And this flip-flop will have the delay will be carried another delta t. So then totally what is the output delay will come, you tell me now? 2 delta t. The overall delay, so it will becomes what, tell me now? 2 into delta t. This is the first thing. And what else you see this thing here? This is what type of counter, you tell me now here? Asynchronous counter. Time period is what you see this thing t. And so then this mod number is how much, you tell me now? This mod number is 4. Mod 4 counter, now tell me. So this output. So time period of this output will becomes what, tell me now? Time period of output will becomes 4 times of clock. Output time period will become 4 times of clock. So you can see now 2 delta t delay and 40. So this is the option you see here. We have a 2 delta t delay is there now at t1 onwards. So for 2 delta t and time period of this output is how much, you tell me now? 40. This is the option. Next, how many pulses are needed to change the content of 8-bit up counter from this state to this state? So how many clock pulses are needed, they are asking. Yeah, first of all, how we need to approach, you tell me now. In this case, previously also we have seen this type of problem, right? So first of all, what is the state they given, you tell me now? This is 1 0 1 0 1 1 0 0. This is the state initially. So can you tell me this value now here? So here 2 3 4 5 6 7. So this value 2 power 7 plus 2 power 5 plus this value to 12 we know very well. So 2 power 7 means what, tell me now here? 64. 64 into 2, 128. And 2 power 5 means 32. Plus this is 12. So how much this value? Tell me now here. 10, 2. So this is 2. And then 2, 5, 5, 6, 7. 7 and this is 1. So that is 172. Now I need to get what is this counter they given now. Up counter is given. So you can tell me now up counter के लिए. If we keep on supplying the clock signal, so then finally the state will come 1, 1, 1, 1. All ones will become, so now tell me. And how much this value you can see now here. So this is 2 power 8 minus 1. How much this value? Tell me now. 255. 8 bits now. So this value 255, 256 minus 1. So will come it as 255 will come. So that means यहाँ से यहाँ तक आने के लिए हमको कितना क्लॉक चाहिए? You tell me now. 255 minus 255 minus 172. So how many you see this thing? 3, and this is so 15, this is 8. So that means 83 clocks are required in this process. Next, इसके बाद और एक क्लॉक अप्लाई किया तो क्या होगा? You tell me now. So all this value 0, 0, 0, 0, 0, 0, 0 बढ़ेगा. Next, finally we need to reach to this state. And what is the state? You tell me now here. So this is 0, 0, 1, 0, 0, 1, 1, 1. Yeah, you tell me now how much now? This is 7. Okay, how much this value? Tell me now. This is 2 power 3, 4, 5. 2 power 5 plus this is to 7i. 2 power 5, 32. That is 30. 2 plus 7, 39. So either how many clocks required now here? 39 clock pulses are required. Isn't it? All of you tell me. So finally, how many total number of clocks required? You tell me now here. So that is number of clocks required. How many? So which is equal to 83 plus 1 plus 39. So you can tell me how much now this is? 123 clocks. So this is option. Okay. Next one. In the figure shown, the initial state of 𝐂𝐤𝐧𝐤𝐬. The output is observed after application of each clock. What will be the output sequence they are asking? Here you need to observe one important thing here. So generally we have seen previously toggle mode connections we have seen. Is it a toggle mode? No. Here it is not a toggle mode. Toggle mode ka matlab in this case what should be now here? Yeah, if the J value given 1, K value should be given from where now Q se dena padega. Then this will be a toggle mode. Then this is a toggle mode. But here see what they given, you see this thing. J value 1, K value given as here. J value given as 1 and K value given as what element of Q bar given. This is not a toggle mode. Okay, this is not a toggle mode and we need to simplify it. Yeah, you can see now here in this case. So if we form a tabular form, you can see the pattern of outputs. You can observe. Right, we have taken Here J value given as 1 and K value which is connected to Q bar. So we'll see this thing, what will be the output. Initial value we can consider it as 0. Yeah, tell me now, let's process now here. 1, this value 1. 1, 1 will come to be a, what, tell me now, toggle. So it is 1. So the J value 1, Q bar is what, tell me now, this value 0. 1, 0 is what, tell me now, set. 1, 0 is what you see this thing here, set. 1, 0 here, then this is set. Yes, 1, 0, and again this is what you tell me now, set only. So this means always this output is coming to be what, tell me now, always 1, 1 only. It is locked in 1, 1, 1. Next. Master slave flip flop is also called as, and what is the master slave flip flop is a master slave flip flop, what type of clock we are using, you tell me now? Level triggered, but it will behave like a pulse trigger. So this is called it as what, tell me now? Pulse triggered flip flop. Master slave flip flop is also called as a pulse triggered. Next. The circuit shown in the figure below uses ideal positive edge-triggered flip-flop, edge-triggered synchronous JK flip-flop. You can see they are asking J value given 1, K value given as 1. So what type of counter is it? You can tell me now here. This is a what type of counter is it? Synchronous or asynchronous counter? You tell me first of all. Synchronous counter, yeah, asynchronous counter. Asynchronous counter, he already mentioned. So we can, from the diagram also, we can identify asynchronous counter. And you can see this thing here, clock. So here this up or down counter, you see this thing here, Q into positive trigger check connected now. So this is plus Q. That means this is in abhi sukh mein aina. या सुख के बाद क्या आएगा, you tell me now here, दुख आएगा. Dukh means which we can say this as a down counter. This is a down counter. So tell me now, down counter के लिए what we can say now, initial state is given as 0, 0. Just before arrival the first clock pulse. Thus they are asking what will be the state after the second clock pulse. So it's a down counter. So 0, 0 के बाद what will come here? 1, 1 will come now. So the option D, 0, 0 के बाद will come it as 1, 1. Next one. A 4-bit shift register given as like this. And they mention that present state is given as a 1101. The number of clock cycles required to reach the state all once. Right. So here we have, this is the D input. And what's the input? You can see this thing here. This is XR between what, tell me now, A with D. XR with A and D now. And let's see this thing. Right, now you can see now, first we can say this as a clock. And we have A, B, C and D. Initial state is mentioned. What the initial state is, you would see 1, 1, 0, 1. What are the states? They given A and D XR. Let's talk about this thing here. First clock. When you apply the first clock, tell me what happens. So XOR between E and D, which is equal to 0. So then it will come to be a 1. This is 1 and this is 0. Next, second clock. XOR between these two, which is 0 and this is 0 and 1, 1. Next, third clock. 1, 0, 0, 1. Fourth clock. 0, 1, 0, 0. Fifth clock. 0, 0, 1, 0. Sixth clock. 0, 0, 0, 1. Seventh clock. 1, 0, 0, 0. Eighth clock. 1, 1, 0, 0. Ninth clock. 1, 1, 1, 0. 10th clock. 1, 1, 1, 1. So that means this is the 10 clocks now. The number of clocks are what is the value stored in the linear feedback shift register if the inputs are given like this. Good problem. Next, first, you need to understand this working first. Right, look at now here. Initially, we have this thing. So then, यहाँ से will come now here. This both will be, we have to do it as XOR and that will be entered here. Yes, first now here. So this input will come now and then thereafter this fellow will come. XOR, no, not this thing, sorry. Yes, this will come. XOR between 1 and 0 is 1. So that 1 will come here and this 0 and this is 1 and this is 1. First step, first clock. When you apply second clock, this 1 and the 0 XOR will happen. That is 1. That is 1, 1, 0 and 1. Next, 1 and 1 XOR. So that is 0, 1, 1, 0. Next, XOR between 1 and 0 will come 1, 0, 1, 1. Next, 0 and 1. 1, 1, 0, 1. Next, 1, 1, 0, 1, 1, 0. This thing 0, 1, 1, 0. So this is the state. Good problem. You right? Take the next one. The initial content of a 4-bit shift register is given. What is the register content after it is shifted 4 times to the right with the serial input being this much? 4 times right shift. Now they are saying 4 times right shift. So this is initial content is given as 1, 0, 0, 0, right shift. Initially first thing. Okay, what is the input being? We need to see this thing here. First, here we have serial input they given as what, tell me now? Input being, what is the first input? You see this thing. What is the register content when it is shifted 4 times only? 4 times has been shifted. So tell me now 4 times. Is input given this side or this side? Okay, if we see this thing, 0 if they given 0, and this is 1 0 0. Next one is 0 0. Yes, so this is 0 1 0. Next, which is 1 1 0 0 1. Next, 1 1 0 0. So this is the content will come now. Next one. The circuit shown consists of JK flip-flop, each with an active low asynchronous reset. The counter corresponding to this circuit is yeah, first of all, what I can do here, this bubble, this bars I'm cancelling here. So I can say this is a clear pin. When the clear pin reset will be activated, we need to see. Okay, for this, what are the pins they has connected here? Here, this is the LSB and this is a MSB, asynchronous counter. So this is Q2, Q1 not connected, and then Q0 is connected. And what type of counter you see this thing here? Q into minus. So that means which is we have in there minus Q. That means this is the duk. Duk hai to duk ke baad we'll get it as a sukh will come na. So that means this is a up counter. Up counter. So then it will come to be a 1 0 1. So this is a mod 5. Mod 5 up counter. Mod 5 up counter. Next, the current state QA QB of 2 JK flip-flop system is given 1 1. Assume that the clock rise time is much smaller than the delay of the JK flip-flop. The next state of the system is. So here this is 5 volts means 1 1 given. J value 1, K value 1. This is the synchronous counter. Synchronous counter के लिए we need to form a table form. And what's the table form you can see? Right, so we can say now J value 1, K value is also 1. Right. So we can say now JA and this is KA. And this is JB, which is equal to what? Tell me now, QA bar. And KB, which is equal to QA bar. This is also QA bar. Then we can have this is QA plus and this is QB plus. Initial state is what element now? 0 0. Now you can see now both are 1 1. Right, QA bar, this is 1 and this is also 1. Tell me now 1 1 ke liye. So this is the toggle. So this is toggle. Right. So now this again, this is 1 1 QA. QA value 0. This is also 0. This is toggle. Oh, they are asking just next state only. Next state means 1 1 only. No need to do all these things. Okay, only that they are asking only the next state only. Immediately next state of the system. Next state is directly 1 1. Next, and which are the following statements are best to describe the orientation of a negative edge triggered flip-flop? So, in case of a negative edge D flip-flop, so what will be the output, you tell me? The Q plus, which is equal to what element of D? The logic level at the D input is transferred to Q on negative edge triggered clock. Yes. When this input will be converted to output, now here D input is transferred to Q. Q is output. On what case now they give a negative edge trigger na? Negative triggering of a clock. Negative trigger of a clock. Yes, correct. Option A. When the negative clock is applied, then the input will transfer to as output. Next, a flip-flop is a sequential circuit and which is edge sensitive in nature. We have seen the disadvantage of a level trigger. The race around condition will occur now. That's why we'll prefer the flip-flops or edge triggered only. We'll prefer it. Next. Now they given a 3-bit down counter is used to control the output of a multiplexer as shown. Okay. The counter is initially at 101. Then the output of the multiplexer will follow the sequence as. Okay. They given it as what element of 1, 0, 1. And they given this as a down counter. If we have formed the tabular form, you can see that. Now you can see now this is A2, A1, A0, and we have now this is S0, S1, and we'll do this as enable. Okay, this is S1 and this is S0, and finally the output. Yes, initial states they mentioned now. This is what element now? 101. 101. This is a down counter. So what is the next state value? 5. 4 will come now. This will come. Here the enable is connected to what element now? A0. This is important. Enable is connected to A0. So this enable is 0. And irrespective of this, if the enable is 0, it is in the hold state only. That means whatever the state we have in this case, this is 1 and S1 is connected to A0. So this is 0. S0 is connected to A2. This is 1. So that means initial state is what element of 0, 1. 0, 1 means what element of 1. So will be in the I1 state. So now also in I1 state only, hold state. If the enable is 0. Next one, so 0, 1, 1. So enable, you see this thing, enable is 1. S1 is A1. So this is 1, 0. So what will come? Enable is active. So will come it as I2. Next 0, 1, 0. So the enable is 0. Then irrespective of these fellows, will come it as I2 only. Next, if it is 0, 0, 1, enable is 1, so 0, 0, so will come to be a what tell me now, I0. Next, if it is 0, 0, 0, 0, 0, 0, so this enable is 0, so it is hold state. Next will be 1, 1, 1, 1, 1, 1, so then it is what tell me now here, I3 will come. Next 1, 1, 0, so then it is 0, 1, 1, then still this is I3. Like this will process will continue. Okay. Next one. In a fourth stage ripple counter, the propagation delay of a flip-flop is given as a 30 nanoseconds. The pulse width of a strobe signal is given 30 nanoseconds. The maximum frequency is. So here they give strobe signal. So this is what tell me now? Time period T clock that must be greater than what tell me now? N into TPD plus strobe signal Ts. So this must be greater than N into TPD. 4 into TPD means 30 plus another strobe signal the delay is given 30. So that means T clock this must be greater than, so this is 120 plus 30. So the time period must be greater than 150 nanoseconds. Time period must be greater than 150. Now from this we can get frequency must be less than 1 by 150. 1 by 150 nanoseconds, that is 10 power minus 9. So that means which is this maximum frequency, which is equal to how much now? This is 10 power 8 by 15. Yeah, tell me how much we can say. 100 into 10 power 6 by 15. 5 threes, 520. So this is 20, means what we can say 6.66 mega I can write now. So option C. Next, for what minimum value of propagation delay in each flip-flop will a 10-bit ripple counter skip a count? That means for the skipping a count, the condition is what tell me now here, time period must be less than the delay. Time period of a clock must be less than the delay. So first of all, we need to find this is the condition without skipping. That means for proper functioning, we used to call for proper functioning. The condition is what tell me now? Time period must be greater than or equal to total delay. If the time period is less, then it is skip the count. So the time period that must be greater than what I can say total delay, 10-bit ripple counter. So 10-bit counter 10. So this is 10 into each delay not given. So let us say delay is equal to something TPD. Okay. So this is the condition. And that means frequency So this is what the frequency means, less than or equal to 1 by 10 TPD. And so from this TPD, this must be less than or equal to 1 by 10 into frequency given as 10 mega, 10 into 10 power 6. So that means TPD, which will come to be a what, tell me now? So 1 by 10 power 8. So that means TPD must be less than, I can say 10 into 10 power minus 9. So this is TPD must be less than 10 nanoseconds. If this condition satisfies, it does not skip. If it is more than that, it will skip now the minimum value. Minimum value they are asking now here. So in this case, we'll skip. In this case, we'll skip. In this case also, in this case also. But minimum value means now we need to select this much, 10 nanoseconds. Next, a cascade arrangement of flip-flops where the output of one flip-flop drives the clock of this one. What we'll call this type of flip-flops are asynchronous counter. Asynchronous counters is also called as ripple counters. Next, the number of flip-flops required to construct a 8-bit shift register. How many flip-flops required to construct 8-bit? 8-bit के लिए 8 flip-flops are required, isn't it? N-bit के लिए n flip-flops. Each flip-flop will use only one output only, ना 1 bit only output. 8-bit flip-flops ना 8-bit register के लिए 8 flip-flops are required. Right. Consider the statement. The race around condition occurs in a JK flip-flop when J inputs are J value, K value 1. Okay, that is correct only. A flip-flop is used to store 1 bit of information. Yes. A transparent latch consists of a D flip-flop. Yes, D flip-flop के लिए characteristic equation Q plus is equal to D only. Master-slave configuration is used in a flip-flop to store 2 bits. No, this master-slave flip-flop can store only 1 bit of information only. Master-slave flip-flop can store only 1 bit of information only. Remember. Okay. Next one. Now tell me, consider the following circuits. The following circuits are classified as sequential circuits. Right, these classes only for the problem discussions. These classes we are focusing only on the problem. If you know the some basic theory, then you can easily able to solve the problems. And you check now whether you are able to follow these classes or not. If you can able to understand the problems what I am discussing, then that means you are comfortable with this subject. Right, consider following statements. Sequence circuits, and full add is a combinational, off add also combinational, JK flip-flop counter 3 and 4. These are the counters. Yeah, the sequential circuits, the topics of definitely you need to attend the complete course, you need to attend. Then only you can able to understand. Remaining you can easily do that one, combinational circuits. But sequential means definitely you need to attend the classes. Okay. Right. So fine, yeah, that's it for today's sessions, and the next class will continue with the next topic will continue. Okay, fine.